So for the question 1, we have fx equal to x to the power of 4 plus 2x cubed minus 3x square minus 4x plus 4. So the first question, we need to find the critical number of fx. First, we differentiate the fx. We got fx cubed plus 6x square minus 6x minus 4. Then we factorize, then we got this. So to factorize the power of 3, we do the test rational roots. At x equal to 1, then we get 0. So from this cubic function, we get x minus 1 times 2x squared minus 5x plus 2. Then we factorize this quadratic equation. We got 2x minus 1 times 2x plus 1 times x plus 2. To find the critical number, we have to let f prime x equal to 0. Then we will get the x value for this equation. We get x plus x equal to 1, x equal to negative 1 over 2, and x equal to negative 2. So this is the critical number of fx. For the question B, we need to find the point of which fx has a relative extremum. So for this, we need to make a sign chart to analyze the changes of the sign at f prime x. So the interval, from the critical point, we do the interval, which is first negative infinity to negative 2, negative 2 to negative 1 over 2, negative 1 over 2 to 1, and negative 1 to infinity. Then we take the test value between this interval, like this. We have negative 3, this is negative 1, 0, and 2. Then we substitute the test value into the f prime x equation. Then we get the sign of x is negative sign, positive sign, negative sign, and positive sign. From this, we can identify the fx is decreasing, increasing, decreasing, then increasing. So first, since f prime x change from negative to positive at x plus x negative 2, fx has relative minimum at x equal to negative 2. So we find the y coordinate. We substitute x into the fx equation, then we get 0. Then for the x negative 1 over 2, f prime x change from positive to negative, so fx has a relative minimum. Here also we substitute f negative 1 over 2 into the fx equation, then we get 81 over 16 for the y coordinate. Last, since f prime x change from negative to positive at x equal to 1, fx has a relative minimum. So as like before, we substitute x equal to 1 into fx equation, then we get y equal to 0. So the final answer is the relative minimum point. We have 2, negative 2, 0, negative 1, 0. And for the relative minimum point, we have negative 1 over 2, 81 over 60. That's all. Thank you.
Hello everyone. Next, I will proceed with the question 1C and D. Let's start. So, for the question C, the question asks to find the intervals on which fx is increasing or decreasing. So, for the question C, we just need to write back the first derivative, which is fx equal to 4x cubed plus 6x squared minus 6x and minus 4. So this is the first derivative that my friend get for the question A. So for the question C, after we already find the first derivative of the equation, we just need to find the second derivative of the equation to find the intervals which whether the equation is increasing or decreasing. So the second derivative is fx 12x squared plus 12x minus 6. So this is the second derivative that we get. Next, after we already get the second derivative, we can also check whether our second derivative is correct or not. And other than that, by obtaining the second derivative, we can determine which critical points that will make the intervals increasing or decreasing. So the first one is we can use x equal to 1. X equal to 1, we just need to sub it. We just need to sub the critical points that we get from the equation A. So x equal to 1, 12 1 square plus 12x minus 6 equals to 18 equals to 24 12 minus 6 24 minus 12 equals to 18. So if we sub the critical number for x equal to 1, we get 18. So this 18 is greater than 0. So the intervals will be increasing. Yes, increasing. Next, we will try for the critical numbers x equal to negative 1 over 2. Negative 1 over 2. Negative 1 over 2. 1. I'm sorry. 2. 12. Negative 1 over 2 square plus 12 negative 1 over 2 minus 6. So we get negative 9 for this equation if we sub x equal to negative 1 over 2. So negative 9, this negative 9, so this negative 9 is smaller than 0. So if the numbers is smaller than 0, so the intervals will be decreasing. So the last one is x equal to negative 2. So x equal to negative 2. Just sub the negative 2 inside the equation. The equation second derivative negative 2 square minus 12 negative 2 minus 6. So this also can get 18, which means the 18 is more than 0 or larger than 0, so the intervals will be increasing. Okay, that's all for the question number C. So we are done with the question number 1C. Next we will proceed with the question 1D. So the question 1D asks us to plot the graph using GeoGebra. For your information, GeoGebra is an mathematics software or apps that help us to draw graph or visualize mathematics easily. So GeoGebra you can get just by using Google or Safari on your gadget. So just like mine, I open the GeoGebra from my iPad, so you can see the graph visually, and then you can see the word input here. You just need to include our original equation. Just like our question, we need to input the first equation, this one into the first input. So this is just easy one. Fx, don't forget to put the fx as well. Fx equals x 4 plus 2x cubed. 2x cubed minus 3x squared. 3x squared minus 4x plus 4. This is our graph. So once you put your equation in the input session, the apps will automatically draw your graph. So just like you can see, this is our graph. We get like the W shape. So as you touch the line, I'm sorry. Okay, as you touch the line, as you done with filling the input with your equation, you can see your critical numbers, your critical points, -2, -2, -1/2, and also 1. So you can also relate to our 1C equation, which are, okay, for x equal to 1, you can see for x equal to 1, the intervals will increasing. The interval increasing, you can see that this one is increasing. This one is increasing. Then x equal to -1/2, decreasing. So the intervals is decreasing, and the last one is x equal to -2, x equal to -2 is increasing. So the intervals is also increasing. So by using this GeoGebra, you will obtain your graph easily. So that is all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is MOHD RASHIDI. Contact number BC250380. Okay. Today we will continue our question, which is question 2, application of differentiation. So given the question, which is we given a rectangle, one side is expanding and one other side is decreasing. And then we have given this rate of change of the expanding side, which is 2, and then the xy area constant for 5 inches. Alright. Okay. We know perimeter, formula perimeter is B 2x plus 1. Yeah. Alright. So rate of change of B when length of side increase 5 inches. So we must have dx dt, dp dt, and dy dt. So we have dx dt which is 2, dp dt and dy dt. Okay. Alright. So finding dy dt, we can use this equation. xy equal to 50. So we can differentiate both sides. We get alright. We know dx dt equal to 2. So we can replace it in this equation. So we can solve this equation and to find dy dt. So, to find y, we can use this equation again. So, y equal to 50. Y equal to 50 over x. Okay. Yes, over x. So, replace it again. We got dy dt equal to negative 100 over x square. Alright. Alright, let's continue. So, we just got our equation for dy dt, which is negative 100 over x square. So then, we want to find dp dt. dp dt, we can get the differentiation by differentiate this equation. So, so we know dx dt equal to 2 and dy dt is negative 100 over x square. So just put it in this question. So we got we just got our dp dt. Alright. So let's continue again. We just got our dx dt, dp dt, dx over dt, dp over dt, and dy over dt. So we must complete this equation. So when the length of a side increase 5 inches. So we just insert the dp dt in here, the 5 in this equation. So then we got negative 4 inch second. Alright. So question B wants to ask when the length rate of change of B when the length of the side increase 10 inch. So just do it the same method. Yes. 400. Then we got 2 inches per second. Alright. For the last question, question C. Rate of change of B when the length of the side increase. Perimeter cease to decrease, which means the X and Y keep expanding and decreasing, but in the same length and same area. So you know infinity equal to 0. So just put it in here. Infinity equal to 0. 4 minus 200 x squared. X equal to 50 and then x is 50 and we got 50 set 2. So, to prove this x equal to set 2, we must know the both sides must have the same value, right? And then 5 set 2, we just insert in this equation. So, 5 set 2 equal to y equal to 15. So, y we got also the same answer. Yes, that's all from me.
Hi guys, my name is SAIFUL bin IBRAHIM and my check number is BC315-117. So I will continue the question, which is the third question. Alright, the question asks about the total cost of producing X rendered set per day is Rn1/4x squared plus 35x plus 20, and the price set at which they may be sold is Rn50 minus half x. So the first question asks about what should be daily output to obtain maximum total profit. Right. The first thing you need to understand and you need to remember what is formula of profit. So formula for profit is profit is equal to revenue minus cost, right? So this one is actually cost, right? So cost, you need to write the whole information, right? The cost is you can write as Cx equal to 1/4x squared plus 25x plus 25. So this one is actually the price, but this one is price for 1 unit, right? So I label as Px. Px equal to 50 minus half x. So this one, right? So for the cost, we have cost, but we don't have revenue, so we need to find the revenue. So to find revenue is actually revenue is equal to x minus x times by the price, which is 50 minus half x. So the revenue I label as Rx. So this one is 50x and half x squared. Right. So we need to find profit. So profit is equal to Rx minus Cx. So we get the R, which is revenue. So 50x minus half to x squared. Right. And minus with cos. Cos we can see it 1/4x squared plus 35x plus 25. Simplify it, we can get 15x minus 3/4x squared. Alright, this is the profit. I label as fx. Fx is profit. So this we get this profit, right? So we need to differentiate this one. So we differentiate as df over dx. So if differentiate, we get this one is 15 minus by 3/2x, right? So this one we need to this one we need to equal to 0 to get the x value. So right, this one 15 minus 3/2x equal to, so we get the x is actually 10. So we need to conclude that therefore maximum profit is obtained when x is equal to 10. When x equal to 10 radio per day is per sec produced per day. Got it? Alright. So the next question is shows that the cost of producing a set is a relative minimum at that output. So the first thing, we need to find the average cost. So the average cost, right, I label as ACX, right? So we need to find this one. So how? So ACX, we take the cost, right? 1/4x squared plus 35x plus 25 over x, the whole over by x. So we get this ACX is 1/4x plus 35 plus 25x the power of -1, or we can write as before over x, right? So this one we need to differentiate. So differentiate dAC over dx equal to 1/4x, we get 1/4, and we get this one is minus 25 over x squared. Right, so this one, right, 1/4 minus 25 over x squared equal to 0, because we need to find the value of x. So we solve this and we can get the x equal to 10. Right, so so this we need to differentiate again, right? So this, it will be 2 squared AC over 2x squared equal to 1/4, right? I complicate. So this is, it will be negative 50 over x cubed. Right. So this is the d squared AC over dx squared. So we find this, right? The value of x is actually 10. So we need to write when x equal to 0. When x equal to 10, so we just replace this x by 10. So C over dx squared. So it is negative 50 over 10 cubed. So we get this is 0.05, which is greater than 0. Greater than 0. So we can conclude that since the value is greater than 0, therefore it is a relative minimum. Alright, so that's all from me. Thank you.
Okay, so let's move to question number 4. So the question number 4 are required us to evaluate the limit by using L'Hopital rule. So look at the first question. We have limit x approach to 0 sin 3x over 4x. The first step is we must check if the limit is indeterminate form. How to check? Okay, so like this. You can see the limit x approach to 0. Therefore, you just need to substitute x is equal to 0 in sin 3x over 4x. Therefore, you will get 0 over 0, which is 0 over 0 is indeterminate form. So, when we got indeterminate form, we must using L'Hopital rule. So here the step. The first step is you must differentiate the limit. You must differentiate upper and lower. So as you guys can see, I do like limit x approach to 0 d over dx sin 3x over d over dx 4x. Then I will got limit x approach to 0 3 cos 3x over 4, and the last one is I will substitute the value of x is equal to 0 into this, into 3 cos 3x over 4. Therefore, the final answer you will get is 3 over 4. And that's the final answer. For 2 Roman, the given limit is limit n approach to infinity 3e power of 2n over 4n power of 2. So, the same step we will use in this question. The first step is we must check if the limit is indeterminate form or not. So here I just substitute n is equal to infinity into 3e power of 2n over 4n power of 2. So I will get the infinity over infinity. For your information, infinity over infinity is indeterminate form. So that's why I use L'Hopital rule. So by using L'Hopital rule, we can rewrite the limit, and then same step again, we must differentiate upper and lower limit. So therefore, we will get limit n approach to infinity d over dx 3e power of 2n over d over dx 4n power of 2. Therefore, when you differentiate, you will get limit n approach to infinity 6e power of 2n over 8n. And the final answer, when you substitute n is equal to infinity, you will still get infinity over infinity, which is it's still indeterminate form. Therefore, you must use L'Hopital rule again. So here, I'll show you. I'll still use a L'Hopital rule again in step 3. So I take the limit and approach to infinity 6e power of 2n over 8n, and then again we differentiate upper and lower. Then you will get 12e power of 2n over 8. Then you just simplify. I just simplify this limit and approach to infinity 12 over 8 e power of 2n, and the last answer you will get infinity. And this is the final answer. And you are done.
So everyone, let's move to the question 3 Roman. So given the equation, limit x approaches 0 positive x squared ln x. So first of all, we must check whether this equation is indeterminate form or not. So when we substitute 0, we will get negative infinity over infinity, which is this equation is in indeterminate form. Next, So when it is indeterminate form, so we can use L'Hopital rule. So L'Hopital rule is that we must differentiate this equation up and low. So differentiate ln x, we will get 1 over x, and differentiate 1 over x square, we will get negative 2x power of negative 3. And then we can simplify this equation and we will get this. And after we simplify, we can substitute the limit 0 power of 2 over negative 2, we will get 0. That's the answer. So the last question is limit n approaches infinity and e power of 2n. So same step just before, we must check either this equation is indeterminate form or not. So when we substitute infinity, we will get infinity over 0, which is not in indeterminate form. But if we want to use L'Hopital rule instead, we can differentiate this and we will get differentiate and we get 1, and differentiate exponent power of negative 2n, we will get negative 2e power of negative 2n. Next step, we simplify as usual and we will get this one like this. So wait, I forgot to put the limit. So we will get this. So the final answer will be infinity as n approaches infinity. So for this question, actually L'Hopital rule is not required actually, because this equation is not in indeterminate form. Since both n and exponential of 2n diverge to infinity and the exponential function dominates, so the limit diverges to infinity. So that's all for question number 4.